Alright, this video is about solving rational equations such as these algebraically, so we won't be using a graphing calculator. First of all, do you remember how cross multiplying worked? If we had a fraction set equal to a fraction and there was an unknown that we were trying to find, we could multiply the diagonals to form a new equation. So x times 9 would give us 9x, and that would go on one side. And then if we do 4 times 6, of course that's 24, and that would go on the other side. So I'd have 9x is equal to 24. Then if I wanted to get x by itself, I could divide both sides by 9. So that's going to give me x equals, and 24 divided by 9, okay, as a decimal is 2.67. Or as a fraction, we're talking about 8/3. Alright, cross multiplying. Now we can still apply cross multiplying to rational expressions. So I can still multiply along the diagonals and make a new equation that's valid. So you know what, before we do that though, let's take a minute and write down what the restrictions will be. Looking at the denominator, we know that x cannot be 6 from this, and x cannot be 4 from this. Alright, the denominators cannot be 0, so that gives us these restrictions. So now let's go ahead and do what I was saying. So 1 times x minus 6 will just be x minus 6. Alright, now looking at this side, x times x minus 4. Let me go ahead and write it down for a second. We will have to do the distributive property. So that's going to give us x squared minus 4x is equal to x minus 6. Alright, let's get everything on one side. So I could subtract x from both sides, and that's going to give me x squared minus 5x is equal to negative 6. But then I would want to add 6 to both sides. So that'll give me x squared minus 5x plus 6 is equal to 0. If this is factorable, then that'll be the easiest thing to do. So let's give it a try. X squared will only be x times x. 6 can either be 2 times 3 or 6 times 1. Alright, let's try the 2 times 3 option. Remember that inner plus outer must equal middle. Inner, I have 2x. Outer, I have 3x. To make negative 5x, they both have to be negative. And that gives me a positive 6, because a negative times a negative is positive. So we have now factored it correctly. To find the solutions, I set these factors equal to 0. Okay, so if I do x minus 2 equals 0, that's going to give me x equals 2. And if I set x minus 3 equals 0, then adding 3 to both sides gives me x equals 3. So these are the two solutions. X equals 2 and x equals 3. Okay, so we just solved our first rational equation. Now take a look at number 2. If I really wanted to stretch it, I could look at this as cross multiplying. If I look at this as 1 over 1, then cross multiplying, I could do n plus 4 times 1, okay, will just be n plus 4. And if I look at the other diagonal, that's 4 times 1. So that's equal to 4. That's one way to think about it. Oh yeah, let's mention the restrictions. N cannot equal -4 because of this. Alright, that reminds me, I need to look back. Whenever you find your answers, you need to just look up and make sure that they weren't restricted values. So 2 and 3, neither one of those were restricted, so we're okay. Alright, so I have this. I can now subtract 4 from both sides. That's going to give me n is equal to 0. So that is the one and only answer, and it is not restricted, so we'll keep it. So that's the answer number 2. Okay, so here again, let's cross multiply. So 4y times 4 is going to give me 16y. And if I do 6 times 2y minus 1, now I can go ahead and distribute this. So that's going to give me 12y minus 6. And again, I'm just doing 6 times 2y minus 1, and I'm doing the distributive property. Alright, to solve this, I need to subtract 12y from both sides. So that's going to give me 4y is equal to -6. Last, I need to divide both sides by 4. So that's going to give me -3/2. Alright, I went ahead and reduced that by dividing both of these by 2. So that is the answer for number 3. For number 4, we will multiply these diagonals. That'll make 20x. And if I multiply these diagonals, alright, again I'm going to distribute. Okay, when I do 3 times x plus 2, that's going to give me 3x plus 6, distribute. But then I would subtract 3x from both sides. So that's going to give me 17x is equal to 6. Last, I will divide both sides by 17. So that's going to give me x is equal to 16/17. Alright, let us not forget to state our restrictions, by the way. Okay, restrictions for this problem. X cannot equal 0 because of this. X cannot equal -2 because of that. Alright, and just make sure that your solution is not one of your restricted values. Okay, similarly, for the restrictions, y cannot equal 0 because of this. Now, if I look at this as 3/1, if I do my cross multiplication, this is going to give me 3x plus 6. And again, when I'm doing 3 times x plus 2, I'm simply doing the distributive property. And x minus 2 times 1 is just x minus 2. Then I would subtract x from both sides. So I will have 2x plus 6 is equal to -2. Then subtract 6 from both sides. So that'll give me 2x is equal to -8. Then I will divide both sides by 2. And that will give me x is equal to -4. Now the restricted value here is that x cannot equal -2. Alright, so -4 is okay. Alright, for number 6, we are going to want to factor both of these things so we can really see what is going on. Now in the numerator, we have a common factor. So if I factor that out, that'll be 2 times p minus 2. If I factor the denominator, p squared is p times p. Now 16, the first thing that comes to mind is 2 times 8. Inner plus outer must equal middle. Inner, I have 2p. Outer, I have 8p. I'm shooting for a middle of negative 10p. I can get that if both of these are negative. And that will give me positive 16 because the negative times the negative is positive. Okay, let's state the restrictions now. Based on these factors in the denominator, p cannot equal positive 2 because of this. P cannot equal positive 8 because of that. And p cannot equal negative 2 because of this. Now, notice that I have a factor of p minus 2 in the numerator and denominator. So before I cross multiply, I'm definitely going to cancel those out. So that's going to leave me with 2 over p minus 8 is equal to 2 over p plus 2. So when I cross multiply, it's going to be like this. Don't forget to distribute. So this will be 2p plus 4, alright, I'm distributing, is equal to and here I'm going to distribute the 2 as well, so that'll be 2p minus 16, 2 times p and 2 times negative 8. So I have this. Something very interesting is about to happen. Because I am going to subtract 2p from both sides, but notice that that will make both p's cancel out. So all that's left is 4 is equal to negative 16. Well, this is not possible. 4 does not equal negative 16. Alright, therefore there's no solution. Alright, if this were a true statement like 4 equals 4, then there would have been infinitely many solutions. Okay, that was the answer number 6. Okay, looking at number 7. As I cross multiply, I will have n plus 3 times n minus 3 on the one hand. On the other hand, I will have n minus 1 times n plus 2. Now I need to double distribute in both cases. N times n is n squared. N times negative 3 is negative 3n. 3 times n is 3n. 3 times negative 3 is negative 9. N times n is n squared. N times 2 is 2n. Negative 1 times n is negative n. And negative 1 times 2 is negative 2. So this will make n squared. Now positive 3n and negative 3n cancel each other out. So I'll have n squared minus 9 equals n squared plus n. Alright, positive 2, negative 1 is 1, and then minus 2. Alright, it's time to subtract n squared from both sides. Now both n squareds cancel each other out, so that leaves me with negative 9 is equal to n minus 2. Now if I want to get n by itself, I will add 2 to both sides. So that will give me n is equal to negative 7. Alright, did we say the restrictions up front? No, but we should have. N cannot equal positive 1 because of this factor. N cannot equal positive 3 because of this factor. And this is the final answer. Alright, first let's state the restrictions. From the denominator here on the left, I see that m cannot equal 0. And you know what? It'll be the same restriction here on the right. Alright, 2m squared. M cannot equal 0 from that either. Okay, number 8, we'll cross multiply here. That will make 2m squared. And I will cross multiply here. And now I'm distributing m times m minus 34. So that's going to make m squared minus 34m. Alright, I need to get these m squares together. So I am going to subtract m squared from both sides. Okay, these cancel out. 2m squared minus 1m squared is m squared. Okay, I need to get everything on one side, so I'm going to go ahead and add 34m to both sides. So, now on the left hand side I have m squared plus 34m. On the right side I have 0 because these cancel out. Alright, let's factor by taking out the greatest common factor. So that'll be m times m plus 34. So that means m is equal to 0. That's one solution. And also m plus 34 is equal to 0. Subtracting 34 from both sides means that m is equal to negative 34. Alright, those are the two solutions to number 8. Restrictions. From this denominator, x cannot equal negative 1. And from this denominator, x cannot equal positive 1. Alright, cross multiply here gives you 4x plus 4. Cross multiplying here gives you negative 3x plus 3. In each case I am distributing 4 times x plus 1, I'm distributing, and negative 3 times x minus 1, I am distributing. Now we add 3x to both sides. That gives me 7x plus 4 is equal to 3. Subtract 4 from both sides, and you get 7x is equal to negative 1. Finally, divide by 7. So that gives you x is equal to negative 1/7. Alright, and that's it for number 9. Alright, let's talk restrictions. Now, from over here on the left, I know that x cannot equal negative 4 over 3. Now, just to be clear, what I'm doing is I'm setting 3x plus 4. This denominator cannot equal 0. And then I'm just solving it. So I'm subtracting 4 from both sides. And so that's giving me that 3x cannot equal negative 4. And then I'm dividing both sides by 3. So that's how I'm getting this. Similarly, because of this denominator, x cannot equal negative 8 over 3. Alright, number 10. Okay, this diagonal we'll set up this way. 3x plus 4 times 2x minus 8. Now the other diagonal will look like this. Equals 2x plus 1 times 3x plus 8. I'm going to double distribute all of this. Alright, so 3x times 2x is 6x squared. 3x times negative 8 is negative 24x. 4 times 2x is 8x, and 4 times negative 8 is negative 32. Similarly, over here I get 6x squared plus 16x plus 3x plus 8. Combining like terms gives me 6x squared minus 16x minus 32. Now on the right hand side I have 6x squared plus 19x plus 8. Alright, so I need to get the x squared terms together, so I will subtract 6x squared from both sides. Now notice that they both cancel out. So that leaves me with negative 16x minus 32 is equal to 19x plus 8. Now I need to get the x terms together. So I could subtract 19x from both sides. So let's see, that looks like negative 35. So I have negative 35x minus 32 is equal to 8. If I add 32 to both sides, I'm going to get negative 35x is equal to 40. Then I will divide both sides by negative 35. And that gives me x is equal to, both of these are divisible by 5, so I'm going to put the negative in the middle. 40 divided by 5 is 8. 35 divided by 5 is 7. So x is equal to negative 8/7. Alright, we need to factor so we can see what is going on. So I have 8 times x minus 1 over x plus 2 times x minus 2. Alright, let's state the restrictions now. From this first factor, x cannot equal negative 2. From the second factor, x cannot equal positive 2. And this third factor would also tell us that x cannot equal positive 2. So those are the restrictions. Watch out for that. Now I don't see anything I can just cancel out. So I'm going to go ahead and cross multiply. Okay. If I do this diagonal, I'll have 8 times x minus 1 times x minus 2. If I do the other diagonal, I'll have 4 times x plus 2 times x minus 2. Alright, equals. Now the reason why I'm not multiplying these out right now is because I see some factors that can be divided out. So if I divide both sides by x minus 2, then these will cancel out. So there won't be any more x minus 2's. Alright, and this will be fine as long as my solutions don't turn out to be negative 2 or positive 2. So if I cancel those out, then so far I have 8 times x minus 1 is equal to 4 times x plus 2. Let's also divide both sides by 4. Alright, I'm noticing that both sides are divisible by 4. So that's going to give me 2 times x minus 1 is equal to x plus 2. Now I might as well go ahead and distribute, so this will give me 2x minus 2 is equal to x plus 2. I would then subtract x from both sides. So 2x minus 1x is just x. So I get x minus 2 is equal to 2. Alright, because these cancel out. And then we would add 2 to both sides, so that'll give me x equals 4. So this is the solution, and it does not violate any of my restrictions, so it's okay. Alright, that's the answer to number 11. Let's state the restrictions first. From the one denominator that we have, we know that x cannot equal -2. Alright, number 12, last one. I can look at this as x over 1. So if I cross multiply on this diagonal, I've got x times x plus 2 is equal to 3 from the other diagonal. Distributing, I get x squared plus 2x is equal to 3. Alright, subtracting 3 from both sides gives me x squared plus 2x minus 3 is equal to 0. Alright, let's see if this will factor. X squared can only factor as x times x. 3 can only be 3 times 1. Inner plus outer equals middle. Inner, I have 3x. Outer, I have 1x. To get a positive 2x out of this, I need a positive 3 and a negative 1. So there's my positive 3, there's my negative 1. Notice that also gives me negative 3 because a positive times a negative is a negative. So this is the correct factorization, and I just needed to set these factors equal to 0. So x plus 3 equals 0, and x minus 1 equals 0. So this will give me x equals -3. And x equals 1. Alright, that was the last problem in this lesson. I hope it was helpful. I will see you on the next video.